Hi, and welcome to our RCR TV program on LTE field testing. I'm Kelly Hill, technology reporter for RCR Wireless News, and I'm joined today by three experts in LTE field testing for a discussion on the topic. Today's event is part of a three-part program on LTE field testing. For more information and to hear more from our experts, you can download the LTE field testing special report from the report section at rcrwireless.com. You can also watch last week's webinar, which is archived on our webinars page. Now on to today's discussion. I'm joined today by three experts in the test and measurement space. Olga Yashkova-Shapiro, Program Director for Frost & Sullivan's Test and Measurement Practice. Andy Standen, Product Manager with Anritsu. And Erik, Director of Product Management for Azimuth Systems. Welcome all.
Thank you.
All right, Olga, I wanted to start with you and ask if you could give us an overview of some of the major trends that are affecting LTE field testing.
Absolutely, Kelly. I would like to start with inter-technology and inter-system interference. It is currently one of the biggest challenges in LTE testing. Another big problem that has always been there but became lately more evident is passive intermodulation or PIM testing. And I'm sure Andy will touch upon that later in this presentation. This is where different systems at different frequencies interact with each other using antenna systems. And because the antenna system is not perfect, degradation can occur in the system at the connectors level. And when that happens, there is a possibility of intermodulation. So it has a damaging effect on the throughput of LTE systems if passive intermodulation. Migration towards remote radio heads is another trend in the industry. In traditional systems, the radio is not exposed to the weather conditions, and it is located in the cabinets on the ground. In remote radio heads, where the radio is located right next to the antenna and is exposed to the weather, the reliability is becoming an issue. Contractors and subcontractors want to do measurements remotely and over the air. Often, LTE is installed in the same location as the legacy systems, and we can find GSM, WCDMA, and also LTE coexisted and often using the same infrastructure. And as a result, there is an increasing demand for testing the existing infrastructure if it is used for LTE for new frequencies. There is also a trend towards test equipment to becoming smaller and lighter, with more features and capabilities built into it at the same time. Another trend is running solutions on standard products. For example, JDSU's handheld solution is supporting tablets as well as Samsung Galaxy smartphone, and ASCOM's recent 10 release is designed to test with an iPhone. Testing MIMO continues to be a challenge as well. As radio technology is evolving from single antenna to MIMO communication systems, there is an increase in spectral efficiency, creating a more complex system. This increase in higher data throughput rate and improved coverage requires more testing, and that's why there is a need for more test equipment. In theory, one needs two receivers in the test equipment to be able to decode the MIMO properly in the field application. However, if two receivers are added to test equipment, the price goes up dramatically. So with all the service providers' recent emphasis to reduce costs, such approach simply would not work. I wanted to use Anritsu as an example, as the company has a rather good technique that can be used to monitor the performance of a base station in the field remotely. And Anritsu also pioneered a technique where service providers can do measurements of MIMO signals by concentration on some of the control signals that are actually transmitted at the same time as the traffic. And lastly, constantly evolving standards. That's another trend that drives the demand for LTE test equipment, as service providers and NAMs must continually acquire newer and better testing solutions to ensure that evolving technologies follow to progressing standards. Carrier aggregation, the 3GPPs release 8 and 9, is crucial for 4G to operate well. The testing of such standards is coming up, and that is why the demand for test equipment is expected to continue rising. So these are some of the key trends in the LTE field test equipment market.
Okay. Andy, I'm going to follow up with a similar question for you. And what trends do you see in mobile communications that are presenting challenges in terms?
Highlighted a lot of the issues already, but a couple of things that I'd like to pick up on is the pressure on us as a test equipment manufacturer to keep costs down at the same time as increasing functionality in a product. I mean, mobile systems today are much more complex than they were 20 years ago. I remember the first GSM installations, and when they were first rolled out, we all marveled at the technology, but that pales to insignificance today when you look at things like LTE and some of the techniques that LTE use. So we're having to build more and more functionality into equipment, but at the same time keeping the cost of that equipment down for the user. And sometimes, you know, those two requirements conflict with each other. But you know, that's part of our challenge. That's something that we have to deal with, and by and large, we are dealing with it. Also, Olga picked up on something or mentioned about interference, and I see that interference is going to be the big issue going forward for mobile operators, especially with co-siting of 2G, 3G, and 4G systems together, often, as Olga said, using similar infrastructure. And when you start to do that, you increase the possibility of interference being produced. For example, the infrastructure that's there at the moment was not necessarily tested at the frequencies that the new systems will be operating at. So there could be issues there that were not actually exposed when it was first tested. PIM, as Olga said, is one of the big issues going forward as well. Olga explained how PIM is generated, and if that interfering signal appears in the uplink of a system, it can certainly affect the coverage and the capacity of that link. And of course, the more systems you have at the site and the wider bandwidth of those signals that are being used, as in LTE, the higher the likelihood of that system being affected by PIM in the uplink. So those are some of the issues that I see going forward, some of the trends going forward.
So Erik, I'm going to pose that question to you as well. What trends do you see in device field testing?
Yeah, so everything that Andy and Olga had already mentioned are things we agree with at Azimuth. You know, from our perspective, one of the key trends is the need to more closely bridge the field and the lab. So in the field, whether we look at interference or even some more fundamental issues like numbers of RATs, radio access technologies, number of frequency bands, number of applications on the device that are you know, leveraging some type of two-way communication with the network in order to provide a service to the customer. I mean, it's simply more complex than it's ever been before. And so whether you're concerned about interference or PIM or, you know, some specific RF characteristics, or whether you're actually looking at application performance on the device, it's more complex. And, you know, probably for the last 10 years, device field testing has been focused a lot on device verification before an operator might accept a device for provisioning on their network. But with all this complexity that's coming up, it's more and more difficult to connect the problems found in field testing with the problems found in the lab. So, you know, when we look at it, we ask ourselves, well, for one, our customers want to see more field testing. They need to cover more test cases, so they need automation solutions that automate a range of applications on the device, because the point of field testing is to get closer to what the end user would experience. And our customers want to benchmark device performance within the context of a user application. So we need to do that, but we also need to have ways to replicate those tests in the lab. Because if you agree that it's a more complex field environment, and if you agree you need to test more test cases, well, we've just made a case for doubling the number of drive test vans that operators are using. And to Andy's point, that's not the direction they want to go in. And so we need to give them solutions that help them identify problems in the field, but then not cost them a fortune as they go through the debug, troubleshooting, and solution implementation. And so, we see the trends as, yes, we want to simplify field testing through automation so that the field test teams can be more productive. But then we need to deliver results in a way that they can replicate the same performance in the lab and use lab-based test beds for everything from development to regression testing of solutions. So that's probably the couple things I'd point to. I'd say it's complexity. It's certainly the need to keep costs down, and from Azimuth's perspective, you solve that through automation and through tools which bridge lab and field test environments.
Okay. One of the other trends that Olga mentioned was the trend toward lighter, more portable test equipment, and I'm wondering, Andy and Erik, if you guys can address that from the perspective of your respective companies' product lineups and how you see that trend reflected.
Yeah. I think if you look 20 years ago, there was no what we call handheld field testers on the market, but that has changed significantly. I think Anritsu was the first test and measurement company to introduce a handheld spectrum analyzer quite a few years back, and the functionality inside that at the time was quite basic, nothing like what you could get in a benchtop spectrum analyzer. But from that initial introduction and talking to customers and finding out what people would need, plus the advancement in technology, devices, and things like that, we were able to keep continuing to get things smaller, but also put more functionality inside as well. And today, we have multifunction testers, base station analyzers, which combine functionalities such as cable antenna testing, analysis, interference analysis, plus all the signal analysis required to do measurements on complex systems like LTE. And that's all contained in a portable, easy to use handheld product, battery operated as well, of course, which is obviously essential in the field. So we see that trend continuing. Obviously, there's a limit to how small you can go, and also you don't want to go too small to make it difficult to use. So there's a kind of trade-off between usability and small size. But certainly, I see that there are still some stages to go in the future to reduce the weight and size of equipment and continue to improve battery life so it can be used extensively throughout the day.
And Erik, from Azimuth's perspective?
Yeah, so there's two ways we'd approach it at Azimuth. At Azimuth, I don't actually make any type of drive test scanner or portable tool in the field, but what we do is provide software tools that allow us to take the results from a handheld scanner or drive test tool or through a modem vendor's diagnostic monitor, and I can take the logs that they create that record field conditions, and I can recreate that in a lab-based test bed using my channel emulator. So from a certain perspective, I'm already super light because I don't add anything to what they're using in the field. I simply leverage what our partners have already developed to increase the scope of testing that we can do in the lab. So that's one aspect. Earlier on, I mentioned automation as being kind of a key aspect of what field testing requires in the future. And at Azimuth, we have a product called Device Automation and Control. And quite simply, we're building libraries that we can use, in particular today, to control an Android device. And using my automation, I can cycle through all the applications that are running on that device. So I can build and implement test plans that benchmark the results of applications running, that I can benchmark the results of FTP downloads of YouTube sessions, and I can simultaneously collect layer 1 and layer 2 performance characteristics from the device. So, you know, from that perspective, the new test device is the handset itself. And I'll automate the handset, and I'll collect layer 1 and layer 2 messaging and other measurements available on the device, and I'll present that in an easy-to-use and assess format to my customers, to whether it's operators or handset vendors. And, you know, I think that's very complementary towards perhaps the higher performing tools that Anritsu or other companies might provide, where, you know, they can look at waveforms and they can look at, you know, highly accurate measures of the radio channel, as opposed to the data that I might collect through a handset. But I look at all these solutions as being very complementary, and it's about coming up with the right cost-effective blend of tools for our customers.
Olga, jumping back to you, Erik mentioned, you know, some of the things that are making, you know, the operators are looking for in terms of testing needs. How do you see testing needs evolving?
I think to add to their need to have more portable, lighter, and easier to use test equipment, in spite of all the complex features and analytics built into it, there's another need that talks about time to revenue. So in other words, how long does it take for a service provider to reap the benefits of their investment into test equipment? And so that's one of the needs. Also, coping up with the evolving technologies in one device. And I believe Erik and Andy mentioned that. So it's becoming very important for the end users of test equipment. You know, I wanted to use JDSU Cell Advisor as an example. So that solution is able to perform RF as well as fiber testing in one test device. And that's just one of the examples. Another important trend and also evolving need is collecting test data in the cloud. And it is vital to hold on to the network intelligence when turning up and optimizing cell sites. And again, as I mentioned earlier, running solutions on smartphones and tablets, as I mentioned before in the case of JDSU and ASCOM, for instance. And also the increasing trends towards so-called end-to-end testing solutions, or field-to-lab, like in the case of Azimuth systems, as Erik just mentioned.
Mm-hmm. Yeah, I know that several of the companies that I talked to, Tektronix Communications and others, you know, really emphasized time to market as, you know, one of the things that they feel is a market driver and a real you know, a pressure that they're feeling from operators as well.
Right.
So let's see. Let's talk about preventative testing versus kind of fix after fail. Andy, I'd like to ask you to address that, and you know, this idea of preventative maintenance and preventative testing, you know, taking on you know, hopefully even a greater role than just put it up and fix it if it fails.
Yeah, I mean, it's you know, we see there's two general philosophies out there, I guess. One is you know, preventive maintenance. The other is fix after failure. And obviously, you know, the test equipment manufacturer would advocate, you know, the preventive maintenance approach. But there are some sound business reasons why that's a good idea. One of the metrics that operators use to get an indication of the quality of the network is subscriber churn, which is basically a measurement of how many subscribers they're losing. Those figures are usually publicly viewable, and you'll see numbers like 1%, 1.5%, even up to 2%. Now, when you consider that they are monthly figures, you can see that, you know, over a year, when you compound that together, they could lose an awful lot of subscribers, up to a quarter of them. Now, there's many reasons why people leave a network, but with us talking to operators and doing our own studies, we think that up to half of the subscribers that churn from one network to another do it for reasons of perceived poor quality in the network, be it drop calls, drop session rates, or bad voice quality, or whatever it is. The problem is with a fix after failure is that the network that's providing all this statistical data back to the operations center doesn't necessarily provide that data in time before a particular site goes down or there's some network problem. So by the time that happens, you know, you've already instilled in the subscribers that, you know, they feel that the network is not as good as it should be, and they'll move away. Well, with preventive maintenance, you know, we regularly go and check cell sites. You can check for trends or see trends over time and take corrective action before there is a significant failure in the network. So you can prevent things happening before they become serious to you. Now, obviously, to do that, there's a cost involved, because you'll need more technicians who will need more equipment to be able to do this. But the benefit to the operator is a much lower churn rate, you know, a better perceived quality of the network. And that lower churn rate will easily pay for, you know, the increased resources you need to maintain the network in the preventive maintenance environment. There is that old adage that says it costs 6 or 7 times more to get new customers than it does to retain existing customers. And when you look at that and factor all that in, it soon pays for itself very, very quickly.
And that was something that came up quite a bit when I was talking to folks for the report, especially with devices. And Erik, I'm wondering if we can talk a little bit about, you know, some of the testing that you're seeing. You know, obviously devices are more complicated, they're smarter, they talk to the network more. And when I was talking with Amit from Azimuth, you know, he mentioned that you know, operators do need to be very, very careful about devices on their networks because of the perception that it's not the device, it's the network. But I'm wondering if you can tell us a little bit about some of the differences between the more traditional conformance or acceptance testing versus performance testing that you're seeing operators do in terms of LTE.
Yeah, so that's a good question and a good point. I mean, conformance and acceptance testing historically, really, it's been about testing the functionality of the device. Does it work? Can it talk to the network? Will it interoperate properly with the different pieces of infrastructure that are deployed on the network? And, you know, to do that, people have tested in a very well-defined and fixed set of propagation conditions, so a fixed set of RF environments. And in many cases, we would just use a standards based environment. In the 3GPP specs, you'll find in several places descriptions of sets of channel conditions that people should use to test. And so conformance and acceptance testing leveraged those definitions of channel conditions in order to do functionality testing of the device. But, you know, as we've all been alluding to, I mean, the world's just a lot more complex than it was even 5 years ago. With bands, protocols, and new applications. And, you know, with the advent of smartphones, and, you know, I think what is the latest statistic I heard is 50% of all phones being sold are smartphones, at least in the developed world.
Oh, at least, I think.
Many of those applications require two-way communication. I mean, it's not just a download anymore. When you start thinking about video and people start having chats with MMS messages, right? So now you're actually sending data both up and down to the device. The way those applications work have a bigger effect than ever before on device performance, and perhaps a misunderstanding of whether it's the network or the device that's causing issues. And so we see many operators stress testing of applications. It's not simply to, you know, check the download speed in an FTP session, but it's to run a YouTube session for 30 minutes. And what we find on some poorly designed devices is that when you start to stress the applications, you start seeing things like stack overflows or buffer overflows in the device that either cause the application to stop working or even to disconnect from the network. And is you need to stress the device by testing it in a real-world environment, which might have poor RF conditions. And when you start talking about it in kind of at a layer 1, layer 2 level, you start talking about ratch attempts. How many times does the handset try to connect to the network and start exchanging data? And at a higher level, you talk about TCP ACK-NACs. So if the uplink is poor, the device might not be able to acknowledge the receipt of data from the network, in which case the network will try to retransmit the data. So signaling and how well apps are designed to communicate with the network can have a dramatic impact on the perception of performance. And again, that just leads back to more test cases and a need for automation in order to run through all these combinations in a repeatable way. I mean, that's probably one of the challenges of field testing, that it's not easily repeatable. Maybe in a statistical sense it is. If you say, well, I'm going to go to the same street corner at the same time of day on the same day of week every day for the next 300 days, maybe you get a good statistical model of what the conditions were, both from an RF perspective as well as from a network perspective. But it's really hard to say if it's repeatable on a day-to-day basis. So, we need tools that will, one, help test a broad range of conditions effectively, and then tools that can bring that back into the lab so that once you've identified a set of conditions that lead to poor performance, you can replicate that as you explore solutions. And so, that comes back to, like I said, what Azimuth is focused on, and that's bringing bridging the lab in the field, bringing the real world into the lab, and then automating it to the degree that we can increase these various test teams' productivity.
Olga, coming back to you, one of the other trends I think that we're seeing in kind of a macro sense in the network, macro, no pun intended, is the movement toward more heterogeneous networks with a greater role for Wi-Fi. We're seeing small cells, maybe not necessarily in huge numbers yet, but definitely part of the plan for network operators. So how do you see Wi-Fi and small cells affecting testing needs?
Wi-Fi and small cells are definitely influencing test equipment, as customers prefer to cover multiple technologies in one device, such as 3G, 4G, Wi-Fi, as well as testing handoffs. If you are using Wi-Fi to offload traffic, you have to make sure that customer experience is maintained, and make sure that offload is as good as your server capacity. Otherwise, operators will face customer churn. The industry is not quite sure, however, of what type of field testing is needed to test Wi-Fi. And at the moment, there is just radio frequency RF power measures that exist. And as far as small cells are concerned, small cells also have a major impact on the cost of testing, as well as the skill of a field technician. Small cells, especially in LTE, have a tendency to improve capacity. So when small cells are used in conjunction with microcells, there is a potential for higher level of interference. The test equipment vendors have to respond to that requirement and be able to measure the interference.
Okay. Andy, speaking of interference, I wanted to come back with you to ask about what are some of the common sources of interference. We've talked a little bit about PIM, and I'm wondering, if you can kind of expand on what we've talked about so far in terms of interference sources for LTE in the field.
Yeah, well certainly PIM is a big one, and it's going to get bigger for the reasons I explained earlier. But there are many sources of interference. Just simple things like other wireless services or refarming of spectrum and I know some operators have fallen foul of refarming, say, WCDMA into GSM spectrum and trying to move the GSM channels far enough away from the WCDMA signals to prevent interference, and sometimes they don't always get the planning right for that. So, you know, other wireless services like that, or refarming, is one issue. Faulty or misconfigured repeaters. I can give you an interesting example of a badly configured, badly installed bidirectional amplifier, which was causing an intermodulation, or what looked like a passive intermodulation problem in a system where you know, a PIM test was done on a cell site and the source could not be found within the system itself. So we were able to actually look beyond the system. One of the things we have in our PIM testers is a function called distance to PIM, where you can actually isolate exactly where in the system or beyond the system the PIM source is. And we just expanded the distance range we were measuring, and we actually identified 1,500 feet beyond the antenna the source of the intermodulation. And it turned out to be a faulty bidirectional oscillator, bidirectional amplifier, 1,500 feet away from the site, which was actually receiving signals from the base station, re-amplifying them and sending them back, but because it was such a bad BDA, it was producing intermodulation products as well. So that was an interesting interference issue. Other things, spurious emissions from cheap transmitters. You know, people are buying many more wireless devices today. Sometimes the radios inside those devices are not fantastic, and they produce spurious emissions, which can appear in, you know, licensed band, causing problems. Lighting ballasts, fluorescent lamps, which use ballasts to, you know, just to regulate the current, they can go into oscillation and cause all kinds of noise and spurious signals. Cable leakage is another one, you know, where there's some fault with the shielding in the cable, or it's worn over time or corroded, or in some parts of the world, people use feeders at cell sites as target practice, and they shoot them, shoot holes in them, and they can obviously break down after that. And jammers. Some people use jammers to prevent people using mobile services in sensitive locations, and you know, that's usually against the law, and it's usually done with malicious intent as well. So that gives you some idea of some of the sources of interference, but I'm afraid it's just going to get worse.
Yeah. Erik, you know, you mentioned you've been talking about applications, and I wanted to follow up on that in terms of, you know, the applications ecosystem is constantly evolving. It's constantly changing. You know, there are some big dogs, you know, Facebook and YouTube and the like. Mm-hmm. But in general, how do you see applications on the device factoring into LTE field testing?
Well, I think, you know, if you look across all the operators, there are certain applications that are used by the vast majority of their subscribers. And they'd be doing themselves a disservice if they did not test at least the performance of those applications on their devices. And those are things like Facebook and YouTube, and, you know, some of the more common applications we all know and perhaps love and perhaps hate, but, you know, they're nonetheless. And so, you know, across our customer base, those applications such as those are a key part of any test plan that we help implement. And, you know, you can look at it two ways. It can be the performance of just the device, or it could be the performance of just an application, or it could be the effects of multiple applications running simultaneously. So, you know, every operator has their own set of pain points where, you know, they've either seen bad results, or, you know, their subscribers have had bad experiences that they want to focus on. But it's a complex problem because, you know, like we've all said, The wireless world is getting nothing if not more and more complex, for multiple reasons, multiple sources of interference, and multiple dimensions of complexity. And we just have to be smart about helping our customers test as much of that as possible and focus on the areas that have the biggest impact on their businesses. And so for that, it's providing platforms. I kind of mentioned it earlier. We have this device automation tool, and it's a platform that lets our customers focus on the testing that most significantly affects their businesses.
Okay. One last question for each of you, and I'm going to ask you each to take a look forward at some of the trends and challenges that you see in LTE field testing in the next few years. Olga, I want to start with you, and can you give us a glimpse of the outlook for the market in the next few years?
Sure. I would love to share some numbers that we came up in our latest research. So basically, the global LTE test equipment market generated over $940 million in revenues in 2012. In 2013, this market is expected to exceed $1 billion mark and generate almost $4 billion by 2019, and that's growing with the CAGR up over 20%. And the LTE field test equipment contributed about $80 million, according to our research in 2012. However, by the end of 2019, it is expected to exceed a $700 million mark and contribute $700 million to the overall market revenues by 2019. And this market is expected to grow at CAGR over 35%. Pretty impressive CAGR from 2012 until 2019. And basically presents tremendous opportunities for test equipment vendors. That's what our research says. And while an increasing complexity of networks and their related equipment brings about a variety of challenges for field technicians, it also translates into better opportunities for test equipment vendors. And one of such opportunities is the conformance testing. While most conformance testing is conducted primarily in a lab-controlled environment, devices must also be brought out to field to ensure that telecommunications equipment operates properly and that customers are receiving high-quality services. Product integration, as it was mentioned, has become an ongoing trend in the communications test equipment industry as more and more features have been added to the testing solution. And because installation and maintenance uses handheld field instruments with integrated features for LTE, these instruments have become smarter, lighter, and smaller in physical size. So these are some of the highlights of our latest research on the LTE test equipment market.
Okay, Andy, maybe we can go to you next, and just kind of take a look ahead. How you see the market evolving and adding more value for operators as well.
Crystal ball, I think there will be a continuing pressure on operators to keep control of costs, which means that the installation and maintenance function will have to be inevitably de-skilled even further, which means from our point of view that we have to make test equipment much, much simpler to use, but maintain the functionality and the capability within it. So much more of a sort of a go, no-go, one button press to do, a multiple set of tests kind of scenario. So we see that trend. We also see a convergence of functionality as well. I mean, we've talked about many different aspects of field testing, drive testing, maybe remote probes, independent of the network, which can do some monitoring, but also the basic RF, layer one type of tests as well. And we see more convergence or, combining the functionality of what today are separate instrumentation into a single product. I think there's still a need for independent verification of the performance of a network. I mean, there's a lot been talked about, SON, self-organizing, self-optimizing networks and all that kind of stuff, and that will be implemented more and more, but some people are looking at that as the Holy Grail, and I can assure you that it's unlikely to be the Holy Grail. There's an interesting saying, which is a very, very old saying, apparently from Roman times, where who watches the guard? When you have prisoners there, who watches the guard to make sure the guard is doing his job properly? Well, I see SON as the guard, but you need some independent verification that the SON is doing its job properly and to its best ability. And I think, in fact, we've already talked a little bit about this, or Olga did, I think, where in fact, everybody did, where we need to improve the correlation between the results that the independent verification gets with what the network is saying, to be able to help the operators or the technicians to identify what component, if you like, right down the component level, is actually failing in the network. So I think there's a lot of work and a lot of development to be done in that area as well. So that's me looking in my crystal ball. Ask me again in 5 years and see if I was right.
Okay, Erik, your crystal ball.
Yeah, so push button solutions, just like Andy says, that's totally, that's front and center in my crystal ball. And you could imagine pushing a button and comparing the results of an automated set of application-based tests that run on the device in the field, and comparing all the KPIs that are produced on that with a lab-based reference test bed. And all with the single push of a button, tests running automatically, both in the field on a live device and in the lab, and then being able to compare in a very meaningful way the performance of those devices. And let's say in the field you saw dramatically reduced throughput, and in the report I show you that the field device had 50 ratch attempts, and the lab device only had 10. Well, there's an indication that the phones are performing differently, and it gives you an area to focus as you start to troubleshoot your problem. So push-button solutions that not only automate the testing, but help organize the results. That's front and center. And then if we look a little bit further into the future, just from a network point of view, I see a lot of features that are focused on what I call multi-link performance. And so today, when you look at a device, we look at the device's performance within the context of a single link. But going forward, we're talking about features such as carrier aggregation, coordinated multipoint. We're looking at HetNet implementation, small cells, Wi-Fi. And the thing that those features do is provide the network operator a way to respond to dynamic field conditions. So, for instance, carrier aggregation isn't simply about doubling the bandwidth by providing 2 channels instead of 1. It also allows the operator to do some load balancing. And if one of those pieces of spectrum has better propagation conditions, and maybe it's at the low frequency cell, so it reaches a little further, well, any user who's close to the cell edge, you'd put on the low band cell, and a guy in close to the macro, you'd put on the high band cell. And so now you give operators ways to dynamically adjust their network in response to changing real-world conditions. And you can do that with coordinated multipoint. You can do that with carrier aggregation. You can do that with HetNet. And so, once again, it's just another degree of complexity that we have to be able to be prepared to respond to. Because now, instead of just testing for conformance, as we discussed earlier, it really becomes essential that you test for performance and test over a range of real-world conditions that would cause these features to dynamically react and change the way they're either scheduling data or, creating handovers of devices between the macro network and perhaps a small cell. So a focus on multi-link and push-button testing. You heard it here. Well, second after Andy, but you heard it here on this webinar first.
Okay, headed toward the Holy Grail then. All right. Well, thank you all. Andy Standen, Product Manager of Anritsu, Olga Yashkova-Shapiro from Frost & Sullivan's Test and Measurement Practice, and Erik Org of Azimuth Systems. Thank you all so much for the conversation today.
My pleasure.
Thank you.